mu s is equal to,
Y sine theta minus FC.
oh, you just call this ft?
No, FC.
FC.
Yeah. Since centrifugal force equals just mass times centrifugal
Alright.
acceleration over y cosine theta. All of that over y cosine theta.
Okay.
So the next step that I did was substituting y into that equation, that thing that we just did. So I had mu equals mg over mu sine theta plus cosine theta times
Sine theta.
sine theta plus, okay wait, now I can change this, minus FC, which equals to mg over, okay, I think
That whole thing times cosine theta.
yeah, is this, so right here, is this a mistake? Because when you're multiplying mg over mu sine theta plus cosine theta, and you're multiplying that by sine theta, do the sine thetas cancel out?
No.
Okay, then that may have been a mistake then.
Alright, do you want me to show you an easier way?
Yeah. Yeah.
Alright, so starting from, I'm gonna take this equation and this equation.
Right.
Actually, color here. I'm gonna keep that negative there and make that equals negative. Factor a y out of, so this is the first equation and that's the second equation.
Okay.
Factor a y out of both equations. We've already done it for the second one, so for the first one, I have y cosine theta plus, oops. All right, I have y times mu s cosine theta minus sine theta is equal to negative mv squared over r. From that equation, I have y already factored out, cosine of theta plus mu s sine theta is equal to mg. I divide. I divide the left sides, I divide the right sides. On the left side, normal force cancels out. On the right side, mass cancels out. So I'm left with all right, I'm going to shorten my notation here. I'm going to let C equal cosine theta, S equal sine theta, mu equal mu sub s. Just the less I write, the less chance I have to make a mistake. So I end up with mu C minus S over C plus mu S is equal to V squared over GR. I lost a minus sign in there, negative. So notice if mu is 0, if it's frictionless, those two terms drop out, the minus signs would cancel out, and we're left with what we did the first part A. I now have two fractions equal to each other. That's a number that we know what V is, we know G,
And we know R.
and we know R. So we can actually get a number for that. And I'm just gonna let that be some number capital A.
Okay.
So now I've got mu C minus S is equal to AC plus A mu S. Get the mu's together. So mu C minus A mu S is equal to AC plus S. Factor mu out. And then we're left with mu is equal to in essence, the centripetal force times C plus S over C minus AS.
Why is, when we're substituting A for V squared, negative V squared over GR,
Yep.
when we're multiplying it by C plus mu S, why does it become AC plus A mu S? Why isn't it negative A mu S?
Alright, did I do a careless error here? So I got mu C minus S, and then C plus mu S is equal to V squared over GR,
Right.
negative. I got this whole thing equal A, and then I multiply both sides by the denominator.
Right.
So I get mu C minus S is equal to, and then I distribute A times C and A mu S. And
Oh,
then,
is it just because, are you substituting like A for V squared over GR or negative V squared over GR?
negative V squared over
Okay,
GR.
I understand what you're saying. That's my fault, I just don't understand.
Would the cosines and the sines not cancel out?
No.
Why not?
Because you can only cancel out if every term, that which is added and subtracted, has the same factor.
I was thinking of multiplication.
Other questions on this studying problem?
Was
Can you not erase that for now?
Yes, please. Okay, he subs, okay, so he does cosine theta, and then he does plus b squared over RG sine theta. Okay, that makes sense. Equals negative over GR. So when we get to that step that you just had,
Right?
oh, okay, wait, pause. When we're getting mu sub s, negative v squared over, yeah, v squared over rg cosine theta. Yeah, no, it's not. Why did I miss it? Plus sine theta.
Can you explain a while back the equation under the red? Mu sub s equals that. How did you get that?
From this equation here, back when that was an equal sign and this was negative, just divided by y, everything by, or both sides by y cosine theta.
So you do move y sine theta over.
Yeah, this was the technique that Laurent was taking.
Huh?
And eventually you would get there. Just, I find the other way simpler, but, you know, the simplest way is, as always, the way your mind is working at the time you need to use it.
So then why isn't it? Oh wait, one sec.
Not related to this problem, but can you remind me what the formula for linear and angular speed is?
For linear angular speed, the relationship,
What's
Is
the
it-
formula?
V equals omega r.
Is that the linear? Or
V is the linear speed, this is the angular speed.
so just the W got omega? Is
Okay.
that just the W, the omega angular speed?
Yes.
Okay. I wasn't sure if it was omega times radius or not.
Well, it is omega times the radius.
Yeah, I meant for angular speed.
Oh, okay. Omega is angular speed by itself. And apparently there's some playground game which exploits this.
What's it called?
It's like with the dragon's tail or something like that.
What?
A student told me about this. You basically stand in the line, holding hands, and then the person is sort of the center point and just starts moving like this. And you see if the person at the end can catch up. Because if it stays rigid, everybody has the same angular speed. But the farther you are away, the greater the linear speed is. So at some point, in order to stay in a straight line as we turn, this will be faster than, well, long enough that it'll be faster than any human can travel.
Is that V? That's not a vector, correct?
Correct, that is speed. Now I could put, it becomes trickier when I throw, a cross product is introduced if we throw vectors into it.
So that V would also be equal to delta x divided by delta t.
Yes.
Dr. Fox, can you, explain number 49 after you're done with this one, just because it has some, like, in your explanation, there were numbers that I have no idea where they came from, and I just need a clarification on how you got certain numbers.
You've ignored the random number generator that physicists do?
Also, I don't understand on number 49 how, like the difference in like units. That's where I'm confused.
All right, so let's start out with, any other questions on number, whatever this was?
30.
Yeah.
30.
Why did you circle v squared divided by r over there?
Because I made the substitution that centripetal acceleration is v squared over r, so I went ahead and did the substitution at that
Oh,
point.
okay.
All right. 49, what is the problem?
Based on Kepler's laws and information on the orbital characteristics of the moon, calculate the orbital radius for an Earth satellite having a period of 1 hour, and then it asks like what's unreasonable of this result, but basically like A has to do, part A is with math, so that's where we're confused.
I assume you end up with a radius less than the radius of the Earth?
Yeah.
Yeah, so.
So all things orbiting the same central body,
Okay.
there's a relationship r cubed over t squared is a constant. So they said using the radius of the moon's orbit.
Yeah, the characteristics of the moon.
All right, so r cubed for the moon over a period of 28 days squared. It's going to be the same for our mystery satellite cubed over the period, which was 1 hour
Yeah.
squared. So that's the relationship we're looking at.
Wait, is that 28 days cubed?
Say it again.
Did you put 28 days cubed?
I did, and thank you.
Okay, so,
And that is HR.
okay,
Well, then I guess we don't really know if it's hours, but it just says 1H, and I just assume that means hours. Like, the period is 1H.
Yeah.
Okay.
I've always used HR for hours and not just plain
Yeah,
H.
I didn't know if that was.
I'd have to double check to see what the official one is.
okay. So, since r cubed over t squared equals g over 4 pi squared times m.
Yep.
We can't answer this problem if we're not given the maths.
No, but this isn't a portion. Like,
It doesn't change the fact, I know how to find it now, but I'm just saying, if we weren't given the maths, how, like, we would be given the maths in this sense, right?
you just need
All right, so the two ways of solving it are one, you either have to look up what the orbital radius and the orbital period of the moon are,
Okay.
or you would go back to the GM over 4 pi squared, or whatever it was, and you would need to know the mass of the Earth.
Yeah.
But it is assumed that you would look up something, or you would be given that information.
So that's like the proper way to do it, right? So if I theoretically plug in the correct radius for the moon, I should get the right answer, right? cause that is what I did, but for some reason we converted to years and got a random radius that I have no idea how we got those numbers.
Yeah, the tricky thing here is units. So,
Yeah.
yeah, the two approaches on units are, one, you can keep track of your units and just end up with something bizarre. Or two, convert it all into the same unit system, like the MKS system, international standard. In which case you'd have seconds in the denominator and the radius would be in meters.
Can you go over r cubed divided by t squared one more time?
Of how we got that?
Yeah. And what exactly it means when you say constant?
How many hours? How many days?
Oh, I know what I did wrong.
I have some central body,
We didn't even know this.
and I have a satellite orbit. If we look at the forces acting on the satellite, it's the gravitational force which keeps it in orbit. So F sub G, F sub G. I know that F sub G is equal to mv squared over r. This is mass of the satellite. So this is F equals ma, this is the equation of motion. Gravitational force is equal to mass times the centripetal acceleration, because it is traveling in a circle. I skipped some steps there. Are you good at this point? So the gravitational force, we're talking the generalized force, so this is mass of the planet times mass, or the central body times mass of the satellite over the orbital radius squared is equal to mass of the satellite times v squared over the orbital radius. So r is this distance here. Assume I've drawn some straight lines in there. I know that the speed is equal to distance over time. So if I look at one orbit, the distance it travels is the circumference, and the orbit is the period. So mass of the satellite cancels out, and I'm left with 2 pi r over big T squared over r, which is 4 pi squared r squared over t squared r. That cancels out with one of those. Bringing all the unknowns or the variables on one side and the constants on the other. Assuming you know the mass of the central body. 4 pi squared, I'll move over to the left, so I end up with gmx over 4 pi squared. Bringing r squared over to the right, I multiply times that, so I end up with r cubed over t squared.
Okay,
So the quick and dirty version of Kepler, whatever, law of Kepler's motion is.
okay, so with that problem, right?
Yeah.
That's the way that I answered it, because like the textbook explains that r cubed over t squared equals gm over 4 pi squared. When I plug all that in, what I'm confused about is like my units. So why, when I put gm over 4 pi squared, what is the measure of time there? Is it in hours? Is it in seconds? Because what I did was,
If m is in kilograms,
right,
and g is 6.67 times 10 to the negative 11th, let's put it in SI units,
right,
then r should be in meters, t should be in seconds.
okay, totally understand that. But my confusion with that is when I do that, so I convert, so t squared in this problem is 1 hour squared. So I converted that to seconds and I put it on the other side of the problem. So I multiplied it by 3,600 seconds. But when I do that, I'm not getting the right answer. And I know it's because of the difference in measuring the
So
time.
r is going to be the cube root of 6.67 times 10 to the negative 11th
Yes,
Newton meter squared per kilogram squared. Times the mass of the Earth, 5.98 times 10 to the 24th kilograms.
right.
Times the period squared, which is 3,600 seconds squared, divided by 4 pi squared. And you got a different answer?
Yeah, I don't know why. Okay.
Did you type it in right? With like all the right parentheses and all
I
that?
did this problem like 15 times, I'm not gonna lie. So if I still made a mistake, that's genuinely my fault. But squared. And then that, oh, not that one. No, I did that too. Let's not get anyone else. The answer I'm getting. Oh my god, I was right. I'm sorry, Dr. Frost. I'm just dumb. That's genuinely my fault. You just converted to like 5.8 times 10 to the power of 3, and I'm looking at my answer and it's like 5 billion O's, something like that.
That's
I'm so
actually
sorry.
not right.
No, it is because he rounds up to 8.
But that's not 10. That's not 5 point da da to the power times 10 to the power of 3.
Yeah, I mean, I
Is
don't
Is
know.
there kilo-
You move the decimal 3 places.
Is there
you're still
kilometers in
fine.
there? They put the answer in kilometers?
Yeah, they did. I think
Oh.
that might be. So it's not.
Oh,
It's not.
So add 3 more
so I have to.
add 3 to the exponent, and then you'll get meters.
So I divide all of that by like 1,000.
There you go.
Okay. Okay, I hate this class. Sorry. Dr. Box, what?
I'm glad we have that recorded.
I was literally how am I supposed
You know,
to
Robin's doing so well, but then she stated in class that she hated it.
I'm just joking. I love this class. Okay, and then I have one last question. Like,
I mean, your brother goes to Chapel Hill, so there's a certain amount of,
I was working on this in front of his face yesterday, and he was like, because my dad was making fun of me because, just so you guys know, my dad and my mom learned my dad learned it in our third world country that, by the way, he barely went to school, and my mom didn't even know English when she was learning physics, but they look at me and they're like, I don't know why you like bio so much, like you're weird. And then my dad was like, here, let me see the problem. And he was just he's just right, like he just said out loud what I was writing down. And I was like, you're not helping me, I don't understand. He's like, I mean, the dude is right, your teacher is right, you're just not smart. And I was like, okay.
I have never said that.
No. I mean, like, he sees the way you're answering the problem, and he's like, yeah, I understand that. I don't know what you're talking about. You just don't get it. I think you're not smart enough for this class. Maybe